Assalamu alaikum. I want to try to make this revision video as short as possible. You know this semester was short. So this is the guide from your examination, the study areas. Those in red, I told you, they are mandatory. They will not appear in the exam. We will focus on this module, Electrostatics. So without wasting time, this semester calculations are few, but have your calculator because we will have some questions, a few questions which require calculator. And remember, I emphasize the use of this function, this one. You must know how to use this for dividing. Okay, let's go straight to lesson 1. So this is lesson 1. Lesson 1, you need to know the types of charges. Types of charges. We said we have 2 types of charges. Positive charges, or the plus charges. And negative charges are the minus. They are negatively charged. These are electrons, and they are free to move. These ones can move. Okay? The positive charges are protons. They cannot move. So when you are charging, they cannot move. So during charging, it's either a material will lose or gain electrons. Okay, Shabab? Don't talk about protons. So if an object is not charged, in other words, zero charge, it is said to be neutral. Neutral means zero charge. N, we use the letter N for neutral. Plus for positive charge, minus for negative charge. Let's go to the next slide. Types of charge, I talked about it. Let's go to the behavior of charges. Behavior of charges. So if the charges are like means the same. If they are the same, in other words, positive and positive or negative and negative, they repel. Know how to write this word, repel. Repel means they move away from each other. Plus and plus is like. Minus and minus, they are like charges. They repel, they push away from each other. If they are opposite, in other words, not the same, or sometimes we use the word unlike. Unlike charges, what do? They attract. Opposite or unlike charges attract. You can see they move towards each other. They come together. We call this attract. Check the spelling. Attract. You can write on your paper the word attract. Definitely somewhere in the exam you will write these words attract and repel. So the particles responsible for charging, we said it is the what? Is the electron, because it is the electron which can move. Proton cannot move. Protons cannot move. Let's go. This is the behavior of charges, either repelling or attracting, depending on whether they are the same or different. Let's go to the next charge. Let's try to answer some practice questions here. Look here. What is happening between the head and the hair of this child? Are they attracting or repelling? The hair and the head are attracting. You can see they are coming together. They are attracting. Check the spelling. Please, you must write these words. These papers, you can see they are pushing away from each other. This one go up, this one go down. What are they doing? They repel. These papers are repelling. Check the spelling there, double L, repelling. And these ones, they are coming together, look. So they attract. These ones attract. So it means if this one is positive, this one is negative. If this one is minus, this one is minus. They are similar charges. If the head is positive, the hair is negative. Let's go to the next question. Another practice question here. Draw. Please take your time to read this. Draw arrows on the diagram. Diagram means the picture. To show the forces. An arrow is like this. Where will this particle go? They are the same. So this one goes to the left. This one will be pushed away to the right. Okay? These ones again, they are the same. They repel. This one goes to the right. This one goes to the left. These ones are unlike. Unlike charges attract. So this one go to the right. This one will be going to the left. They are coming together. This is attraction. Repel, repel, attract. Next question. Understand the methods, the three methods. You must understand, this is from page 127 of your book. You must understand the three methods of charging an object. When you read here, the first method is conduction. Conduction. Conduction means touch. You bring an object, a charged object, to touch the object which you are charging. So there is touching or there is conduct. Conduct means touching between the object and the charged object. That is charging by conduct. Then induction. There is no touch. The charged object and the object being charged, they are not touching each other. You just bring near. You bring it closer or near the charged object. Then there will be movement of electrons. Please, we talk about movement of electrons only. It's the electrons which move. Either move away or move into the object. The third method is charging by friction. Like this. Charging by friction. When two objects are squeezing on each other, look. Maybe this one gain minus. When the minus move from this one, this object becomes positive. We are charging by friction or by rubbing. When objects rub against each other, we are charging by friction. One object will be negative, another one will be positively charged. That's what I'm trying to show you in this picture. We are charging by which method here? When you move, your shoes are exerting friction between your feet and the ground. So you are charging by friction or rubbing. This is what is happening here. The charges that move are electrons. I told you, they are electrons. So here, this object is showing what is happening between the charges minus and minus. This object will move away and this one will be pushed back. These ones are unlike. The objects come together, they attract. So please, you must understand this concept. Okay? The three methods of charging. So here, let's answer these questions. Look at the three students, Maitha, Sam, and Ali. Which student is charging the object by conduction? In other words, there is touch. Conduction means there is touching between the object and the charged object. It's same. You can see these objects are touching. So it's same. It's charging by conduction. friction or rubbing. Who is rubbing one object against the other? It's matter. Okay, Shabab? Induction means coming near, no touch. You can see here there is no touch here. So this is who? Ali. Okay, Shabab? Let's go to the next question. Abdullah is rubbing balloon A. Okay, this is balloon A against a silk jersey. Ahmed rubbed balloon B. This is A and what? And B. You can say CA is positive, B is minus, negatively charged. They then placed the balloon at a distance of 12 centimeters. So from here to here, this is 12 centimeter. Okay? State the method by which these students were, by which these balloons were charged. Look, they were rubbing. So the correct answer can be rubbing or friction. You can write friction. Another one can write what? Rubbing. These are all correct. And they mean the same thing. Balloon, which balloon gained electrons? Look, electrons are negative. Electrons, you must understand this. Electrons are charged minus. Which one gain or take electrons? The minus is B. The negatively charged object or charge is B. While balloon dash lost electrons. When you lose electrons, the object becomes positive. So it's A. A become positively charged. It loses electrons during the charging process. On the diagram, draw arrows to show. You draw on the diagram arrows to show the direction of the movement of each balloon. You can put A there, B here. A is positive, B is negative. So they move, they attract, they move together, they come together. Or you can draw here. Okay? They come together. Explain why the balloon would move like that. They are attracting. So you say unlike charges attract. Okay? Calculate the force between the two balloons. Now we use Coulomb's law. We will come back to this after explaining Coulomb's law. F equal K Q1 Q2 over R squared. We will explain this after talking about Coulomb's law. It's in the next slide. Let's move on. We will come back together. Back to this slide. Let's finish about charging. Describe how Air Emirates get charged during its trip. Look, the flight Air Emirates is rubbing against wind or air. So there is rubbing between the aeroplane and the air. So by rubbing. Sorry, energy in there. Rubbing. It's energy. Rubbing against the wind. By rubbing against the wind. This is friction. The method is called friction, by friction. You can simply write by friction. Why should the aeroplane or the airline be discharged? Discharged means remove charge. Discharge means why should we remove charge? If passengers go out without discharging, they will be shocked by the static electricity. So, to avoid this electric shock, we discharge the aeroplane first before passengers go out to avoid electric shock. On passengers, okay? Or on people. The people traveling by the airplane are called passengers. They will be shocked. Okay. Look at this. Put the missing charges on the other balloon in each set from A to D. So if this is plus, they are repelling. This is repel. Like charges repel, so this is plus. Repel again, if this is minus, it means this is minus again. They repel, moving away from each other. C, there is no force. So this is N means neutral, zero force. So this is also neutral. No force. Okay? Here, these ones are attracting. Which one's attractive? This is minus, it means this is plus. Unlike charges attract. Also name the type of force. We have named the forces, okay? Here there's no force, it's neutral. Okay? You need to know conductors and insulators. Look here. If I connect here with a wire, here, the charge will be able to move and light the bulb. So materials where charge can flow, they are called conductors. Conductors like copper, all metals. Metals are conductors. Copper, iron, aluminium, they allow charges to move. But here, look, if I put rubber here, like ceramic, rubber, wood, these are insulators. They do not allow charge to move. Insulator. So these are insulators. Insulators. They do not allow charge to move. You must know what these words mean. Insulator and conductor. Let's go to the next slide. So this ones is the same what I was talking about. You can answer these ones quickly and show me in the class. These are just revision questions for you to know what happens with the like charges, what happens with unlike charges, okay? The force between stationary charges is called electrostatics. The force between stationary means not moving. The force between stationary charges is called electrostatic force. Electrostatic force. Static means electrostatic means not moving. Electrostatic force. The type of charge on an object can be tested by so to test the type of charge, whether positive or negative, we use a gold leaf electroscope. We will talk more in the next slide, electroscope. But you know this is the project which I told you to make a gold leaf electroscope. We use it to test charge. We will discuss it in detail in the next slide. I want to make this short. Charging by induction. Induction means no touch. You just bring near the charge. You bring it near the object, or no touch. The charged object is not touching the object. Like here, I bring it near. So the minus, the negative charges will push away electrons. When the electrons move away, what remains are positive charges. This is the process of charging by induction. You bring the charged object near the object, it will push away electrons and attract protons. And now when you separate, this object will charge the positive and this will be charged negative. Remember, you separate this when this one is still there. Okay? After separation, A is positively charged and B is negatively charged when you separate. Let's go to the next. This is your homework. Tell me what happens here. If this is positive, what charge comes to A? What charge comes to B? Remember, plus will take the minus, will attract the minus, and what remains here are positive charges. So now, when you separate them, A will be charged negative and B will be charged positive. This is charging by induction. Let's go to the next. You will be tested on the uses. Why do we study electrostatics? Where do we use this knowledge? 1, in spraying cars. Look what we are doing. The spray is negative, the car is charged positive, they attract. We want the paint to attract on the car. That's number 1. Another use, removing charged smoke, photocopying, and lightning, to prevent lightning. Using lightning conductors. These are the uses. Where do we use this knowledge? You must know this, okay? Let's come to Coulomb's law. This is the last part. Remember, there's one question up which we have to solve using Coulomb's law. This is Coulomb's law in words. This equation is Coulomb's law in symbols. Coulomb's law in symbols. What is F? It's force. Equal a constant times QA times QB is called the product of charges. This is the product. Product means times. Product of charges. R squared is the distance squared. This R squared. You can say square of distance. Check the spelling, Shabab. Square of what? Distance. It should be in meters. Remember, to change centimeters to meters, we divide by 100. Always. So if they say state Coulomb's law in words, they will ask you about this. State Coulomb's law in words. Let me assure you, this question will be there. You have to know to describe this equation in words. You will say the force between charges equal product of the two charges times a constant divided, look at the spelling, divided by square of distance. Force equals a constant times product of charges divided by the square of distance. Simple. You get yourself some marks. So this is the force F. Charge A, charge B. The distance between the two is our R. But remember, we will square this R. Let's go to now, how do we use this equation? How do we use this law to solve problems? Let's say we have two charges. The force is F. Okay? If R is doubled means 2. Double means times 2. Times 2. R is equals to 2. R is equals to 2. Okay? What is the new force? So you check here on this equation. You use this equation. Did we change K? Did we change K? No. So the number is 1. When you don't change something, put 1. Did we change Q1? No. So I put 1 because we only changed R. Did I change Q2? No. So I say times 1. Divide. Did I change R? Yes, I doubled. So I will say divided by 2, but the 2 is squared. 1 times 1 is 1. Divided by 2 squared is 4. So it will be 4, 1 over 4 F. So the new force is 1 over 4 F. Know this. This one is coming, I tell you. If R is trebled means times 3. Let's see the new force. Did I change K? No, so I put 1. Did I change Q1? No, I put 1. Q2 again, I put 1 because I did not change. Did I change R? Yes, I treble. Means I put 3 squared, which is equals to 1 over 9 F. Let's go to this one. When I half means 1 over 2, which is 0.5. R is now half or 0.5. Did I change K, Q, and Q2? No, so I have 1 times 1 times 1. Did I change R? Yes, 0.5, but it's squared. 1 divided by 1 divided by 0.5 squared is 1, it's 4. 4F. Okay? This part is coming. One question, you have one question on this. So you have to revise. Let's come to solving questions. I said this word micro, it means times 10 to the minus 6. So if I say 4 micro, it means 4, the number is 4 times 10 to the power minus 6. 3.5 micro. What is that number? It's 3.5 times micro is 10 to the minus 6. This is the number. 8 centimeters, how many meters? You say 8 divided by 100. I said to change centimeters to meters, you divide by 100, which is 0.08. Okay? 20 centimeters to meters, you divide 20 centimeters divided by 100, 0.2 meters. Practice with this one. Tell me what is your force. First of all, you have to put your formula. F equal to K, Q1, Q2, divided by R squared. Remember the number for K. Always K is equals to 9 times 10 to the power 9. So I will put numbers now. K is 9 times 10 to the power 9 multiplied by Q1. What is the number for Q1? 20 micro. So it's 20 times 10 to the power minus 6 times 15 coulomb. There is no micro, so I just take the number 15, divide. What is R? R is this distance. 2 centimeters divided by 100, 0.02. So it's 0.02, and it should be squared. 0.02 squared. Tell me what you get from your calculator. We will do this one together. Okay? For practice, further practice again. Okay? Before we do this one, let's go to the one I avoided before. Where is that question? Is this one. So this is what I was saying here. What is the number K? 9 times 10 to the power 9. What is Q1? 2.3 micro. So 2.3 micro is times 10 to the power minus 6 times Q2. What is Q2 there? Is it 3? 3 times 10 to the power minus 6 divided by R is 12 centimeters. 0.12. Tell me when you put in your answer. I told you the force is in newtons. I told you how to put numbers in the calculator, okay? Tell me the answer when we go to school or on my WhatsApp. Let's go to that question. We were here, yes. We will answer this one only. These other ones I will give you for practice, okay? Let's answer this question. Study the two charged particles A and C. So we have A and C shown below. Okay, it's A and C. Answer the questions below. State Coulomb's law in words. Remember, Coulomb's law is, we have to write this formula. We have A and C, so I will write QA and QC divided by R squared. I have to put this in words. So I will write here force equals force between charges equals a constant times QA and QC, it's called product of charges times product. I'm simply writing these words, this formula in words. Product of charges. I go down. This line means divided by. Divided by square of what? Square of distance. Distance between the charges. Okay? Charged particle has gained electron. Which one has gained electron? Gain means, remember, electron is the minus. So which one is minus? It's C. Gained electrons because it's negative electron. While particle has lost. Which one is lost? When it loses electrons, it becomes plus. Which one is plus? It's A. On the diagram, draw the arrows. We did this question below. On the diagram, we said they are attracting. So they come together like this. Calculate the force between the two balloons. We use Coulomb's law, F equal to K, Q1, Q2 divided by R squared. The number for K, I told you, always it's 9 times 10 to the power 9. What is Q1? 4 micro. So it's 4 times 10 to the power minus 6 times Q2 or QC, which is 3 times 10 to the power minus 6 divide by R squared. What is R? 5 centimeters. You have to divide 5 centimeters divided by 100 is 0.05 meters. We use R in meters, so it's 0.05 meters squared. Don't forget to square. What answer are you getting? Take calculator. I'm getting calculator 43.2 Newton. Please check if you are getting this answer. If you don't get, maybe you are making a mistake somewhere. This one I will give you for practice. Tell me the answer when we meet at school. And this one again for practice. This is from your book, page 133. This one again for practice. Tell me the answer. You use the same method. The same method here. If you forget, put the same method, only you change the numbers. Let's go to the next question. Again, this one is for practice. Tell me the answer. F, what is F? How many newtons? Formula and the number, then answer. How does the magnitude of the electrostatic force F change if R is doubled? Look, R is what? R is doubled. Doubled means times 2. R is doubled. 2R. R is doubled. So from the formula F equal to K, Q1, Q2 divided by R squared. We did not change K. K did not change. It's 1. Q did not change. I put 1. Q2 did not change. I put 1. So it's 1 times 1 times 1. R is doubled. It's now 2. So double means 2 squared. What is it? 1 over 4. 1 over 4F. 1/2, no. Quadruples. Quadruples means times 4. No. Becomes 1/4. 1/4 F. Yes, this one. Okay? It becomes 1/4. The last one, the gold leaf electroscope. Look at this one. We use it to test charge. To test the charge. Okay? Look what happens if you bring a minus, a negatively charged object. The plates or the gold leaf, these ones, these are called gold leaf. They rise. Why? And they are like charges. Here, this one is minus, this one is minus. Like charges repel. Repel. So like this, the minus and the minus, they repel. That's why the leaf rises. So we use it to test the type of charge. We will answer some questions. Okay, you can read this about the gold leaf electroscope. We use it to test the charge. Let's come to this one. We did this in class again. A student figure shows a gold leaf electroscope that has been given overall negative charge. So the gold leaf is charged in minus, okay? Minus. A student connects a metal cape. Connect the metal cape of the charged electroscope to the ground with a piece of wire. So he now connects with a wire here. This is a wire. Remember, a wire is a conductor. It allows charges to move. Why did the leaf rise? This is rising, going up. Why? Oh, first of all, this one. Use these terms to label the parts A to E. So what is A? A is the cap. What is the B? Is the metal rod. B is the metal rod, the wire. C, this one is the gold leaf. Check the spellings. Gold leaf. D is the insulator. And E is the earth. Check the spelling here. Earth. Okay. Why did the leaf rise? Why did it go up? Because negative and negative are like charges. Like charges repel. You remember what we said here? Like charges repel. The negative charge are they protons or electrons? These are electrons. I said electrons are negatively charged, okay? Describe in detail why the leaf falls in 2B. So 2B here, when you connect the wire, the minus charges go to the earth. So the electrons flow out to the earth. Remember, this one becomes zero charge, not charged. It is discharged, no force. You can say there is no force, or the electroscope is discharged, or the electrons flow out to the earth and there is no force. Okay? State where we can use static electricity in UAE. I showed you here. Where can we use static electricity here? In UAE for spraying, removing smoke, photocopying, and lightning conductors, okay? So where do we use this? We said the spraying, in photocopying, and lightning conductors, and in photocopying or removing smoke, photocopying. When you want to make copies, photocopying, you use static electricity. This one I give you for practice again, for you to practice the calculator. Okay, Shabab, I think we are done. Thank you, Shabab. Salaam alaikum. If there are a few questions, I will tell you. Remember, we have more practice questions. I gave you test 1. Yes, this one. These questions, I send you these questions for you to practice multiple choice questions. You have this one I sent to you on Telegram. You should practice using these questions. They are there on Telegram. We did this. This was our test 2. This one, and also which one? Yes, this one. You remember this question? These questions, just use them to practice for your multiple choice questions. There will be 15 multiple choice questions and 3 writing questions. Okay, Shabab? Like this. Salam alaikum, Shabab. This is the end. I'm saying do your best to pass. There will be 15 multiple choice questions. Let me write on another slide. Okay. I cannot do this. I said there will be 15 multiple choice questions times 4, 60 marks. Practice multiple choice is very important. Then there will be 3 writing questions. Writing questions. 40 marks. So this is it. Salam alaikum.